to Unify's webinar on an introduction to WPF and XAML in Team Developer 6. This is your host, Paul Lavelli. We do have some new people joining us for today's webinar. So for those of you that are new to the Unify Corporation, we are a publicly traded software company and we have been in business for about 30 years. Unify is probably best known for the first company to deliver a relational database to the Unix environment in the early 80s. And since then, we've delivered software development products that run across different databases and platforms that are really geared to building and modernizing business applications for the business application developer who places a premium on productivity over low-level coding. Now today, our business has expanded beyond database and development products into migration solutions as well as e-discovery and email archiving. For today's webinar, we do encourage questions. So if you do have one, please use the Q&A button on your WebEx toolbar. This is the button that is marked with a question mark. There is also a chat feature, but it makes it much easier for both Martin and myself to just look into a single panel just to make sure that we answer all of your questions. Today's presenter for Team Developer is Martin Tietz. Martin has been with Unify for over 15 years in various roles, including support engineer, product marketing manager, and I believe most recently Director of Product Management. And Martin is joining us today from Germany, and it's a great opportunity and a real privilege to have someone with his background and experience with Team Developer today. So with that, I'm going to go ahead and turn it over to Martin.
Thank you very much, Paul, and welcome from my side as well. Today we are going to talk and chat about mostly XAML, and all this is a let's say easy introduction to XAML, so you understand the methodology behind it, the idea behind it, and then if you have time available tomorrow, the same time actually, you can see how all that ties into TD. Today I will more give an overview, give you a little sample. Tomorrow in the webinar we will be showing you in depth how all that works in Team Developer. So here's today's agenda. I'm going to talk about what is XAML, the underlying concept, the syntax, binding, and styles. I will talk about how Team Developer uses XAML, demo, how that looks, and of course we will have a Q&A session where you can ask all the things you want to know. Maybe you already tried TD6 and have some specific questions that you want to ask or you want to know. So the quick definition of XAML. XAML equals extensible application markup language. It's an XML-based language and heavily used in WPF, Silverlight, and workflow. In WPF, XAML is used for the layout of the GUI and for resources used by GUI application. That means you can also provide data using XAML to controls, for example. Why XAML? If you look at a bit older technology like MFC, WinForms, MFC basically would equal to Team Developer Win32. The GUI is heavily tied to the business logic. That is the case in C++ and in Team Developer. The look and feel is very static. To provide any level of customization, you had to change a lot of properties. And so as languages are evolving, basically as an example, web design, the GUI and the GUI and the code actually have been separated. So on ASP, in the Microsoft.NET, in the Microsoft world, before ASP there was ASP, before ASP.NET there was ASP, and if you remember ASP, or if you ever looked at an ASP page, you could see that the ASP page actually contained the HTML for the page plus some code, JavaScript or Visual Basic code that were all in one page. And that has changed with .NET and the coming ASP.NET, where you have a single file for the code and a single file for the GUI itself. And the same has happened in the Java world, where Java server pages have evolved into Java server faces, where code and presentation are divided. WPF and XAML bring this model to the desktop GUI. So you basically have one code area and you have one UI area. The GUI and the business logic are strictly decoupled. Why to do that? It is easier to develop a model view controller style application where you can change parts like the data model, the layout of the application, and the business logic, which is the controller part, without affecting other parts of the application. This allows designers to focus on look and feel, and the engineers can focus on developing code. They don't have to share one file where you know what problems there are with that. If done right, controls or even entire applications can be lookless. Lookless controls. The UI and the code are strongly decoupled. The developers provide a default template for what the control looks like at runtime. The users of the control can easily provide their own templates that completely redefine what the control looks like. Actually, you will see a sample later in this webinar where I override an existing TD control using XAML and provide a totally new user interface for an existing control. And still the complete API, the business logic behind that works as before. Many applications make use of XAML capabilities, for example, Microsoft Expression Blend, of course, Visual Studio, Yahoo Messenger, and more business applications that are out there that have been developed in .NET and WPF, and of course many of our customers that are starting to work on TD6 and WPF applications. So what is XAML? What you see here on the left side is the XAML markup, which is the XML code that defines what you see at runtime on the right side. So basically on the right side, if you see, look there, there is a main window. That main window contains a tab, and on the tab there is a push button. And if you look into the markup language there, you will see that there is a tab control, there's a tab item, so just very much like in TD, and there's a grid and a button. You don't really see the grid. The grid is, in this case, is more a let's say a container for stuff. So that's a basic grid that doesn't have any rows or columns really, and in this case used as a container. And there's this code behind model, which is very similar to ASP.NET. The X class definition defines which code behind is the UI is linked to, and you can see on the left there is a main window class, and then below that class is the namespace definition for that class, which refers to a source code. In this case, the source code is not TD, but this is what our developers used when developing the TD6.0, which is C#, I guess. And you also see the button in the code, and the button has a click event handler called button onClick, and that button onClick is then is in the code defined as a private void method, button onClick, and in that button onClick method there is a message box that shows up when somebody clicks on that button. So this is basically how the UI is tied into the code. The UI, the XAML, contains a click event handler, and that is being called, that calls the code at runtime. And you don't have to do things like that when you do a TD application on WPF desktop or browser. The event handlers are all being created automatically for you. It's just for you to an introduction to understand how all that works. So, for example, you have a My button defined in XAML, then that My button needs to be coming from a namespace, which is this XML-NS colon, and then the assemblies and namespace, and then there's a control implementation. In Team Developer, all built-in WPF controls, all built-in in Team Developer and in .NET WPF controls, buttons, text box are mapped to a default prefix, so no prefix is necessary. If you use third-party controls, a prefix must be mapped, so you need to provide a namespace in front of all the XAML definitions you would like to do. So the control properties and events are set using XML attribute syntax, and you can see that again here in the XML code on the left, and you see the text of the button and the clicked event handler, my button clicked, and that then executes the clicked event handler. And that is stuff that in TD you don't have to care about. The only thing you need to remember is that you don't change these things. If we, in our XAML code, put in a click event handler that has a certain name, then you shouldn't be changing that, because if you change that, then it won't be able to find the code behind anymore. XAML syntax, a few things about the hierarchy. As you've seen before in the first example, I guess, with the grid actually did only contain a button. Some controls are a container for other controls. Children are added by defining them as child nodes in XAML. So basically in this thing here, you have on the top level, you have a stack panel. You see that XML definition of a stack panel, and at the end of the stack panel at the bottom. And then in the stack panel, you have a tab control. In the tab control, you have a tab item. On a tab item, you have a button. And on another tab item, you have another button. So basically, this is a tab control that has two tab panes. Each with them has a button on them. So if you look at the definition of a button in XAML, basically, what does a button contain? A button can contain a host of XAML properties like the border, gradient backgrounds, hover effects. It can contain pretty complex brushes, like, for example, round brushes with color effects. So it's pretty powerful, and you will see some example of that pretty soon. And here's the example for that. The control guts are all XAML too. So everything that makes a control is defined in XML text, and you see all the elements of a button are defined in strict XML. Be it a color gradient or several color gradients that are being added together to provide a complex color filling for a button, like this here with several gradients in there and start and stop colors, and you see that. You can actually use, I think, tools, design tools, where you design something visually and then save that as XAML, for example, and then you see pretty complex code that describes how that XAML defines let's say, a round button that has gradient colors in it and has hover over effects and things like that. Now in XAML, control templates can easily be overwritten at local or application level. What that means is that you can basically provide a new design for something that is available today. For example, a button that TD has, the standard application button with the gray background with a little bit of gradient on it, you can completely replace that with your own definition of a button that can be an ellipse with several color gradients on it with hover over effects. If you would like to, you could even provide animations on that written in XAML. So XAML-Binding is something that is not yet available in TD. It's just a technology that's available in XAML that I'd like to mention, because that's something that might be available in future versions of TD, really. And that is a powerful mechanism for linking properties to data without code. So basically, you can bind properties of a control and the contents of a control to XAML data. XAML-Binding can be one or two-way. The changes in the user interface are being pushed back to the data object or not. You can have validation. Anytime the data is changed, custom validation logic can be applied. And you have value conversion. You can provide custom data format strings with no code. Now what that means is that we have interesting possibilities for future TD versions. For example, that you have functional classes that support data binding. For example, you can bind UDV instances to WPF controls or entire UDV arrays to a WPF control, which would be quite interesting and easy coding going forward for you. So that's something that we are looking at for the future. XAML resources. XAML resources are basically files that you provide which contain resource dictionaries. And these resource dictionaries can either provide resources like, for example, translations of the controls, buttons, for example. You can provide a German version of your application just by providing a XAML resource dictionary. You can provide an English version just based on the resource dictionary. And these resource dictionaries allow you to actually override existing XAML styles that have been created in TD, that Unify has created in TD, and you can provide new look and feels for all the controls of TD. Resources can then be used by referring to their key. You can use the static resource statement to resolve values at compile time. Actually, I will show you that in an application to localize an English application to German, for example, or the other way around. And there's also XAML also provides the possibility to use dynamic resources, which are being evaluated at runtime. That's something that we use internally, but that is not exposed to the developer, really. Let's talk a little bit about how TD uses XAML. TD WPF applications, so that is WPF desktop and WPF browser, use XAML for all of their windows, all of the user interface that is being displayed. The themes of Team Developer are implemented using XAML resources. Our UI uses dynamic resources to pull in theme resources. This means it's easy for end users to provide their own theme. And if you're interested in doing your own Team Developer themes, then I strongly suggest that you also attend tomorrow's webinar, where Gary Betancourt will demo exactly that. So, the compiler for XAML. In the TD Designer, you design forms, menus, fields, etc. And the TD.NET compiler converts UI to XAML. And the XAML is then being reconstructed to the UI at runtime. Team Developer creates one XAML file for every top-level window. So all the windows that you see in your application are being converted to XAML files, as you see here. And you can actually, these XAML files are all text files that you can edit. For example, in Team Developer, you created this wonderful form window, and if you look at the XAML of that, this is how that looks. You see the first line contains the X class and the namespace definitions, and then all the visual parts are being defined with toolbar, button, and other things that are being shown here. Now, this is a TD-generated XAML. Here's a list of the TD WPF controls and the names of the controls that are being used in XAML. For example, a push button in XAML is called SAL button. A data field is, depending on the data type, either a SAL text box string, SAL text box decimal, SAL text box date. A background text is a SAL label. Grids are being generated. Toolbar is a SAL toolbar, and so on. So these names are important if you want to override the design of these guys on your own, because then you provide a new XAML design for these names. If you look at window properties in the Attribute Inspector, you see all these things there, images, all the image definition, and exactly that image definition is being converted to a XAML definition automatically by TD. And on the right side, you see the XAML for a button, for example. The exact position as defined in Attribute Inspector, and the exact behavior, exact design that you choose in Attribute Inspector. The window actions, and here again, this is the binding between the GUI and the code behind. In this case, the code behind is not C#, but is Team Developer. On the left side, you see all the events of a button, or the provided events of a button: onsem click, onsem create, onsem set focus. And you see the XAML definition of that button. It's a SAL button. The name is pbtest, as you see, and it has a clicked event handler, which is called pbtest_clicked. There's a create event handler, pbtest_create, and a set focus event handler. And these event handlers actually call the compiled Team Developer code at runtime. And you shouldn't be messing with these names. As soon as you do that, your application is broken, basically. You can play with all the other things, with the design, but not with the names of the event handlers. What about object inheritance? No XAML is generated for window classes. XAML basically does not support the Team Developer style inheritance. So what we do is we have a flattened UI for all the XAML that we generate. So basically, every window contains all the definitions that are provided from the class. Object inheritance. This one here is a special case that you also need to know if you work with classes. As soon as you don't use the Team Developer base class for a button, you need to provide a different override name, or you need to override the class name itself with your definitions. To achieve the sample above that you see with the round or the ellipse buttons, you need to override the SAL button, and you see that at the bottom, SAL1:SAL button, xname pb1, and then if you also want to have the class button, which is the class cpush, and you see SAL2:cpush, xname, you can see that I didn't even rename those buttons, it's pb2 in my code, and that applies the round button design to that class. So how are GUI and code linked? The XAML UI parses the SAL code and then executes the event handler that have been generated for some click and some create, for example. So next thing is XML is nice to look at and nice to read. Actually, it can be quite complex to read if you look at some of the nicely designed samples where tons of gradient colors have been designed. It can be quite overwhelming, but that also, all this text also means it's quite slow. So the performance penalty is pushed to the compile phase because we use something like BAML. So at compile time, TD takes all the XAML files, or generates all the XAML files, including those that you changed, and compiles those into a binary format called BAML. And BAML is much more compact, and parsing is very fast compared to the text-based XAML. So basically we take the XAML that you created, that we created, and compile that into BAML, and then drop all that into the .NET executable that you get out, be it a browser executable or a desktop executable. So you get a nice and quick user interface. The auto-generated XAML files that TD creates. There's one file which is called app.xaml. The app.xaml file holds global application resources. TD doesn't really put anything into there, but this is a good place for you to provide custom resources, be it language resources or your own style definitions. And style definitions are basically visual object definitions. And window main.xaml, which is an important file for TD, and you shouldn't mess around with this file. It contains the main startup window that is necessary, and this file is actually different for browser and desktop applications, but there's nothing you can do with that one really. How does TD benefit from XAML? You are not limited, as a TD developer, you're not limited to what's exposed in the designer or to the objects that we provide. You can create, additional to the themes we provide, you can provide custom themes for your applications. You can provide integration with other controls. You can create very advanced layouts and styles. And you have easy localization of the UI using resources. So all this talk, let's have a look at all this. First, I want to show you how to localize applications using XAML, and then I want to show you quickly how to override a control like a push button using XAML. So what I have here is actually the TD60 DEFCON sample that we showed at DEFCON 2 years ago, which was the first prototype of TD.NET. And this application, let me open that application, is, let's say, a localizable application. And this dialog box, dialog invoices, has contents that are translatable, and you can see that instead of the object title, there is a XAML static resource definition and the name of the button there. So rounded brackets, static resource, PB, apply invoice, round bracket closed. That defines that the XAML resource with that name will be pulled into that place there. That means you have a compile time language definition, so to speak. However, and that if you look at other buttons here, you will see the same, that all these have this XAML definition in the object title here. And of course, if you look at that window, that might be easier even here. You'll see that all these have static resources. I didn't do all, but a good bunch. And these will pull at compile time, will pull in the names of these resources from an XML file. So let me quickly show you the XAML linking there. So in TD6.0, if you have a WPF application and you started to save dialogues as XAML, then TD will create a .xaml directory below your application directory. And in that directory, there is another directory with the name of your application. That is that if in case you have multiple applications in one directory, the XAML doesn't get messed up. Each XAML is in its own directory again. So what you see here is a app.xaml file. Then you see a German resource file and an English resource file. And you also see a round button resource definition here. So let's have a look at app.xaml. And app.xaml is really a very short piece of XAML that basically includes this resource dictionary and basically tells TT to pull in this resource file en-en.xaml for an English application in this case. So let's quickly run this application. I compile this application. This is now a WPF.NET WPF desktop application which is running in debug mode, and need to note on performance here, if you run .NET applications in debug mode, we actually create a debug exe and run that debug exe. That is why it's slower when you create the final exe from the build menu. So there are different file formats being created, one having debug information, one not. And this one has debug information. So I open that dialog that you saw in TD before, and you see all the button texts are in English and the other text in that form as well. And you can also see that I have overwritten one single button with a round button design here. You know, if you want to go into details of how to do that, that's really the topic of tomorrow's webinar, just as a give you an idea what you can do here. So if you want to change this application to be a German application, or you want to compile the German version of your application, then all you do is put in de.xaml, save this file, and let me now just open this resource file as well. What you see in that file basically is a bunch of definitions, and you see the X key, background 1, PB print invoice, and that defines the language resource here. So basically at compile time, TD now pulls in the German language, and we should get a German dialog now if I run that sample again. Starting the application in debug mode. Opening the dialog, and you see it pulled in the German names here for all those objects where I did provide that static resource thing. So this is one use case. Let's look at another sample. Overwriting control styles using XAML. Let me go into that directory here. Speedbar. So what this does is basically taking a C-meter control. As you can see here, this dialog contains a C-meter control. See the contents here, C-meter. And if you provide a value, then that value will be passed to the C-meter as the current value of the C-meter. Now, you all know how that C-meter looks, basically the horizontal progress bar. And what our developers have done now, they have done some magic and provided a new look and feel to this progress bar. And let me show you how that works. In app.xaml, what you can see again, there's a resource dictionary being pulled in, which is called progress template.xaml. Let me open that file. And here you see a bit longer XAML definition already. So this is pretty detailed definitions of a new control, which is basically a speedometer, a car dashboard control that replaces the horizontal progress bar. And important part here is this X-type SAL3 : progress bar. This actually overrides the standard progress bar with a new speedometer progress bar. So this is the magic here. And now let's look at this. Execute that in debug mode again. And here we go. If you enter a value here, that value is being displayed using the speedometer now instead of a horizontal progress bar. So this is kind of the magic you can do with XAML if you want to. But you can of course use all our controls as well and don't mess around with that at all. But I think this opens interesting opportunities for displaying values in applications where you get values from machines, or you have QA values coming in from several machines and you want to display like the measures of objects that have been created, if they are in the allowed range or not, and things like that. So very interesting things can be done using that, and they can be based on standard TD controls that get transformed into something new. So let's come back here. We are in the Q&A part of the application, of the webinar. And again, more on how TD uses XAML is available in tomorrow's webinar, Extending TD Apps with XAML. Gary will go into much more detail on how you can manipulate TD applications with exciting XAML things, including how to create your own, total own themes.